in the for model structure, we are going to be looking at the various elements in model. There are a lot of physical elements, there are demand elements, and these are sort of the building blocks of a model, and we'll see how they relate to various structures and various processes in Visum. And the model structure is Visum follows a layered approach where each physical object is represented as a separate layer, as we saw, in the interface overview. There are, each network object here is a separate layer. Nodes is a separate layer. Links, turns, zones, everything is a separate layer. So you can apply settings to each layer separately, and the layers are independent, so they can have their own graphical settings or other configuration settings. All right, so yes, as I said, each object type is contained in its own layer, and because of that, you can visualize these layers separately. So in this session, we'll quickly bounce back between the version file and the slideshow. So let's quickly go to the let me just try to bring my network editor back. And we don't need, I can just tag it down here. Okay, so this is the network editor. And right now, let me just zoom out a little bit so that you can see this as a little bit more detail. And I'll use the, the pan icon to navigate easily. Just giving it a few seconds for it to load. And as you can see here, it's a layered approach, and as I mentioned before, it sort of follows the sequence of model development where, you would start with nodes and links and so on. And you can, because of the layered approach, you can easily switch between views. So right now I'm looking at, all the nodes, and then you can quickly activate the links layer, and then you're looking at all the links, right? So that's a layered approach, and the advantage of a layered approach where all the layers are sort of independent, but and you can apply settings to each layer independently. Okay, so we'll look at these, model elements or the building blocks in more detail now. So let's start first with nodes. And nodes in Visum, they are junction points between different facilities. So it could be an intersection, or it could be a merging, or a diverge point. So all these locations are represented as nodes in Visum. And these could also represent boundaries. So let's say in your network, a speed change is happening, a section of road where it goes from a speed limit of 60 to 40, the node might be needed there to act as a boundary between those two different speed limits. And then, there could be the actual boundary of the node itself, if area type is changing or something else is changing, or number of lanes are changing, so those sort of boundaries, for those defining those sort of boundaries also, you would need to include a node. Okay, so and then for each for node, there's also associated data with each the node layer, and this would include information about physical attributes such as what's the control type, the capacity, the name of the intersection, number of legs, and things like that. And it can also include outputs from the model. What's the travel time or volume or level of service and things like that. And you can access the node data from again, you can open the node list, and that would give you access to all of this data. Okay, so let's quickly jump to Visum again here to take a look at nodes in a little bit more detail. So let me quickly um, switch on the node layer, and for now I'm going to switch off links, and then I'm going to activate the nodes layer. So um, I think they appear a little bigger, and so let me just quickly change the graphical parameters to make it look a little more better. So this is how, in case you want to change any of the visual settings, you can simply right click on the layer and then go to edit graphic parameters. And in the display, so the size right now is 3, so maybe we can make it 1.5 for now. And you can preview if you want to see how it looks. And then if it looks, I think it looks okay, so we can say okay for now. And so let's see, let's look at a few of these nodes just to understand how nodes are defined. And maybe we can look at some of the uh, downtown Jacksonville area here. So as you can see, nodes are defined for intersections and in anywhere where diverging is happening or merging is happening. That's where nodes are defined. If I click on any of these, it would open the quick view window for nodes where you can include more variables that you want to look at. But if you want to edit the nodes, you can simply double click on them and make sure you're using the edit mode, which is this arrow symbol on the this taskbar on the network editor panel. And if you simply double click, it would open up the Junction Editor, and you can look at different things here. You can look at the geometry to understand where the node is, and this will be more complicated if you're looking at an intersection where it would show you the geometry of the intersection itself. But there are many settings can be updated through this Junction Editor, and that is how you can edit a node. Okay, so let's go back here. If you want to look at what's data is there for nodes, again, right click on the layer, and then you can go to list, and it would open the node list with all the data that is stored for each node. So there are things that we talked about. There are control type, the actual coordinate of where the each node is located in this projection, and then there are a lot of other user-defined attributes that could be defined for nodes. And most of these are imported from previous models, but you can define things like the county that contains this node, and things like that. So that's all about nodes. Let's once you have the nodes built in, you can add links, and links are essentially facilities between those junction points. So they connect two nodes, and then links also contain a lot of physical attributes of the road, such as road names, speed, number of lanes, curvature, distance, and so on. And also model output data, variables that are computed by Visum, things such as congested speeds, volume, or travel time, etc. So all of this, the link data contains all of this. And to access this link data, you can open the link list. So again, it's the same way that you would open a linked list. You would right click and then click on list. And in case of link, you would find two options as link and link types. So in Visum, you can define link types, which is essentially a way to group links. So let's quickly look at that and it would be more clear. So let me switch on links and switch off nodes for now and activate links. So now when I'm in the edit mode, so when I move my mouse, it would highlight various links. And so let's look at some of the links here and what data is associated with them. And another thing to note here is, in Visum, links are bidirectional, meaning they have both directions. And so which direction are you selecting depends on which side of the link you are on. So, if I hover on the right side, then the arrow appears here. But if I hover on the other side, the arrow is on this side. And once I'm there, I can click and that direction is selected. And the data for that direction is displayed here in the quick view window. And if you want to edit a link, you can double click the link on the network editor window, and it would open the edit link box here, where you can see various attributes such as a name, length, and what's the V0 is the unloaded speed, number of lanes, and capacity, and all of that. And there are other things such as the transport system. So in Visum, you can define various types of modes, which are defined as transport systems. And then on each link, you can open or close the link to certain transport systems. So if you, let's say, if a roadway is to be used only by buses, then you can close that link to all other transport systems besides local buses. So that it gives you a lot of control that way. And then besides these transport system and all these variables, there are also user defined attributes. So these includes things such as area type, or you can include counts, or any other variables that you would require for any of the operations in the model. So things like tolls or service minutes at various links, and then you can create separate fields for storing volumes and for generating reports and so on. So and the transport systems you can access from here. So the link that we selected looks like it is not open for transit, but it is open for other modes. But you can select various transport systems here, and we'll talk about transport systems more in a bit. But each link can be given access to or close to certain transport system. Another button that you would see is the opposite button. So as I mentioned, the links are bidirectional in Visum. So every link will have data for both directions. So once you open the edit link window, you can edit both directions just if you say opposite, it would go to the other direction. But before we do that, one thing that you note here is that the transport system window and also various other boxes, they are highlighted in yellow. And the reason for that is the other direction of this link is closed. And you would see that in a minute. If I click on opposite here, you would see that none of the transport systems are selected. So this is how you would close a link in Visum. You close the link to all transport system, and that essentially closes a link or makes a link, one way. Okay. So that was all about editing a link. And if you look at some of the, let's look at some of the highway links here. Let me close the background for a minute here so that I can move fast. Okay, so now when it comes to highway links, they are like divided directions, or like even divided arterials. And for such roadways, you would have a link going in each direction. But some of for undivided arterials, for such you would have only one link, and which would serve both directions, because links are anyway bi-directional. So here, let's say if I click on this, it would I'm trying to double click. It opens the edit link window, and you can again see the opposite direction. It's yellowed out. That means the opposite direction is closed, because this is designed as a one-way link. And if since the natural flow of traffic is in this direction, if I were to select the other direction, you would see that the arrow width suddenly changes, because it signifies that this direction is close to traffic. So a thick line would indicate that you're that's the natural direction of traffic flow, or traffic is allowed in that direction. Okay, so if you want to access linked list, you would come here, right click, and then you can go to lists. And then if you select link, it would open the link list. And one thing that you see here, which is usually important, is the type number of the link. So links in Visum can be grouped by a type number, and this just helps in mass editing links. So all the arterials, or undivided arterials, may have a specific type number. The freeways may have a specific type number. So if you want to update all the freeway links, then this type number field can be used to apply all those mass editings on those link types. And if you want to look at what link types are there, you can again go right click on links, go to list, and then look at link types. So it shows you a complete listing of all the link types, and what are some of the common common attributes for those link types. Things such as so that they are like the BPR function parameters that are shared by same common link types. Another use of link type is link type in combination with area type. There is a field called area type, see right here. So these could be used to mass edit, or code speeds and capacities for each link. So in NERPMAB, the speeds and capacities are not coded, but they are coded on the fly using a speed capacity lookup. So in order to access that, you can go to lists and then go to user defined tables, and then let's go to table entries here. And then by default, it opens this dasim config table, but you can switch to a different table by clicking on that where the name of the table is, and then scroll your way to this table, which is speed cap, and then you can say confirm selection here. So this is the speed capacity lookup. So in the network preparation step, the Visum uses this speed capacity lookup. So this has a facility type, the type number that we were looking at, and the area type and number of lanes. And based on that, it assigns speed and capacity to various links. So in future, if you want to, um, update the speed or capacity on any of the link for if you're modeling a new scenario, then the way to do that would be to go to the speed cap lookup and see for the given links, area type and facility type, what is the speed and capacity that is being applied, and change the area type or facility type of the link accordingly to apply a new speed and capacity. So that was all about links for now. Let's go back here. And so once you have links and nodes in your network, the next step is to include zones. And zones in Visum, they act as demand generators and attractors. So they store land use or demographic data such as population and employment and school enrollment and things like that. And so let's go back to Visum and let me switch off the links layer and switch on zones and activate zones. And let's just zoom out a little bit. So you would see zone polygons, and again, it's the same concept. If you want to change the graphic parameters, you can go to zones and then edit graphic parameters if you want to visualize them in any different way. If you want to edit a link, you can simply click on any of the polygons here, make sure that you are using the edit mode, and then you can double click, and that would open the edit zone window, and you can change various things here. If you want to update any of the user defined attributes, you can do that. Every zone is sort of connected to a centroid connector or a zone connector. So let's switch on the zone connector layer, and it would show you all the connectors. So, and zones can have multiple connectors. Since we are not able to see the connectors, let me quickly change the graphic parameters and maybe we can change the line color here and make it maybe more bright. Just preview it, and we can increase the line width also. Okay. So now you can see the connectors, and each zone can have multiple connectors depending on the size and how you want to load the network. Generally, smaller zones will have fewer connectors, and larger zones will have more connectors. And these connectors, they they access the network through a node. So nodes sort of provide the gateway for the demand. The demand is generated at the zone level, and then it accesses the network through the connector and through a node, and then it goes on to the entire network. And then again, for net connectors too, you can control various things. You can assign which transport systems are can access those connectors, and then you can also define user-defined attributes. For zones, we did talk about the zone data. So if you want to access zone data, you can go to, again, right-click on zones and then click on list, and this would show you all the zone level data that is there in the network. And typically you would see variables like geographic indicators like area type and county and name of the zones, etc. And then you have other demographic data like employment or you know uh, total dwelling units, total population, and the auxiliary models, they require variables such as the uh, distribution, auto ownership distribution for single family versus multi-family households, and number of dwelling units, and things like that. So all of that data is stored at the zone level because the auxiliary models, they operate at zone level. One thing that let me switch off the connectors for a minute. One thing that I forgot to mention was that zones can be both polygons and they can be points as well. And you can always import polygons or nodes, and then import them from a shape file, and then assign them to zones. So in NERPMAB, you would find zones both as polygons and nodes. So in NERPMAB, there are certain zones that are buffer zones, or they are sort of zones saved for for future use, but they are not used actively right now. So, and they are located outside the model boundary. Let me quickly zoom out to the location where we can find those. So instead, you can search for a zone if you want to, using this find network object feature. You can go here and then you can search. Let's say I want to look for this zone. This is one of the buffer zones, and if I say zoom, it would take me to that locations. So in this case, we need to set the graphic parameters file so that we can view those external zones. So let's we can in fact load a graphic parameters file for this setup. So let's say I load this graphic parameters file, which says activate TAZ. So in order to load a graphic parameters file, you can simply drag and drop it to your network editor panel. And then, you can say read all graphic parameters at this point. And if you say just OK, it would, open the graphic parameters file for you. And then you can see like there are a lot of these buffer zones, and these buffer zones could be, external stations. Excuse me, buffer zones and external stations are different. So external stations are, the normal external stations, and they are represented as points. But all the other internal zones, they have a polygon. Okay, so that's all I wanted to talk about. And for zones, let's go back to the slideshow here. Okay, so besides zones, there is another object called points of interest. And points of interest, again, could be anything. It could be a point, it could be a line object, or it could be a polygon object. Now, if you would remember, NERPMAB operates at two geographies. So it operates at TAZ level and then also at MAZ level. And DSIM operates at MAZ level. And TAZs and NERPMAB, they are represented as zones, but MAZs are represented as point of interest. So let's look at points of interest and how MAZs are defined. Okay, let me go back to Visum here, and let's quickly zoom out. Let me close the links for now and only keep the zones, and the POI layer is right here below this first section. You would find it here. So right now it's switched on. Let me switch off the zones also for a minute so that you can see all the POIs. So POIs are representing MAZs in this model, and MAZs, I think they follow the resolution of census blocks in this model. So there are a lot of MAZs, close to I think 55,000 or so, and they get pretty dense when you get to the downtown. So let's maybe look at the downtown section of the network, and you can see there are very small MAZs. And for the POIs also, it follows a similar system where you can click on. I think I have the zone layer activated. That's why when I clicked it, I selected a zone. So let's activate the POI zone, a POI layer. And now if I would click on the network, it would select a specific, MAZ or the POI. And then you can again double click on that, and it would open the edit POI window. And you have sort of similar things here. Um, you have user-defined attributes, and then there is also something called as allocations. So this tells you, which other network objects this POI is associated with. So, there's this node, probably that must be the centroid or something that this POI is associated with. But if you look at the zones, it would give you the ID of the parent TAZ for this MAZ. So this framework or the system could be used to represent both MAZ and TAZ in Visum. And then using this allocation, it gives you the relationship between MAZ and TAZ, and that can be exported as a crosswalk. And that becomes an input, let's say, for population sim, because it requires a MAZ to TAZ crosswalk. So that's something we will look at when we work our way through some of the scenarios in tomorrow's session. We'll talk more about how to update these allocations. So POIs also have a list, and I'll be using the term POI and MAZ interchangeably, because in Visum they are called as POIs, but for NERPMAB maybe we are representing POIs as MAZ. And you can have more than one POI layer. So currently there is only one POI layer, which is MAZ. So you can have maybe if you want to have census tracts also represented in the model, you can add multiple POI layers and name them differently. But in this model, currently there's only one POI layer, which is representing MAZs. Okay, so let's if you want to look at the associated data for MAZs. Again, it's the same process. Right click on the layer, and then you can look at the list, and it would open again a similar tabular data table. And currently, because we have only a single POI layer, it doesn't matter. But if you have multiple POI layers, you might want to select the right POI layer. And for each list, the list display also gives you the total number of those network objects. So in this model, there are 55,184 MAZs, and that many rows will be there in that list. And there are other cool features, in a list display. If you want to quickly, check out the sum, you can use this the sum access feature, which would give you sum of each column. Then if you want to look at total employment, total educational employment, you can quickly use that to see what's the total employment in this region. In NERPMAB, most of the land use data is stored at the MAZ level. So, the employment data and population and things like that, you would find them here in this table in the point of interest list. And the data is also segmented by the model year. So currently, there are 3 years that come with that are included in maybe the base year 2015, and then there is a 2030 forecast year and 2045. So all the socio-demographic data is there for all 3 years. So here you have employment by different types, and then there is also household ID, number of households for 3 years, and then there is data like parking rates for each of these MAGs, and that is something used by DaySim. And then there is also university and student enrollment data for each year. And if any of this, especially the employment data, exists both at MAZ and TAZ level, but the TAZ level data is aggregated from MAZ data. So if you want to make any changes to your land use data, you should always make it here in the at the MAZ level, because the TAZ level data gets updated from the MAZ level. But there are certain attributes that exist only at the TAZ level, and for those, you should only look at the TAZ level data. I think the hotels data is one of the variables which is specified only at the TAZ level. So you would not find that variable here. So if you want to update that or edit that in any way, look at the zone list and update it there. Okay, so that was all about POIs. That's something different from a tree-based model, that there are 2 geographies in NERPMAB. There's zones which are representing TAZs, and then points of interest which are representing MAZs. So let's keep going. We looked at the POI list. So another element is transit stops. So transit stops are similar to nodes. They define a junction point or gateway points between public transit network and other other modes, such as walk access to transit or drive access to transit. And generally, stop can represent anything. It could be a simple boarding location, a physical stop, or it could also be a transit center or a park and ride station. So, it's very quite flexible, and you can code transit in quite detail in Visum. And then once you have transit stops, you can overlay transit lines over them. And for each line, you can define transit routes. There could be different routes for each line by time of day, or if they go northbound versus southbound and things like that. So you can define routes, how the different routes for the lines. And then for each of the routes, you can define the frequency by defining headways, and then also, fares and other things could be defined for those transit lines. Okay, so before we go forward, let's quickly look at how lines and stops look in Visum. Okay, so maybe let me switch off the POIs here, and you can scroll to access stop points and lines. These are the two things that we would be looking at. So let me switch on the stop points, which are stops. And since it's not very clear, let's load a different graphic parameter file here. We can maybe we can load the transit edit GPA, and again you can simply drag and drop it into Visum, and then you can say okay here to read all graphic parameters. Okay, there we go. So let me switch off the point of interest layer so that we are looking only at stops and lines here. So let me activate the stop point layer, and then you can click on various stops, and again you can look at various data for stops, and then there are also lines, and when you activate the lines layer, it would open this window and it would show you the line routes. So the line routes define so if you click on a line route, it would highlight that line route and show you where exactly that is on the map. But and if you want to look at the line data, you can right click on lines and then go to lists, and then you can look at the line level data or line route level data, or you can look at time profiles. So in the line data, you have again the name of the line, and then the transport system code, if it's a bus or rail, depending on what transport systems you have defined for your model. And then fare system set, what type of fare system is it using. And then there are some uh, fields which are grayed out. So generally, whenever a column is grayed out, it means it is a reserved column, meaning it is generated by Visum. It is a calculation or it is an output. If it's white, generally it means that you can edit that field. And since we haven't, we are looking at a initialized version file, so there are no volumes or boardings at this point, and there are some user-defined attributes which have boardings from a previous run, I believe. Okay, so let's go back to the network editor again, and maybe let me go to the stop points. And so one of the nice feature, let's say the legend here is only showing stop points, but you want to show lines also. So you can go here and click on this small box. So it says edit legend. If you click on that, it would open this legend parameters box, And here you can, select other, different things that you want to be displayed in your legend. So right now there are only nodes and stop points, but you can include things like route courses. You can preview how it looks, and then you can say okay, and then now it displays different route courses by transport systems. We did cover how to interact with various Visum elements in much more detail in some of the other trainings. So if you're interested, I would encourage you to go check out some of the previous D1, D7 trainings. There's also a lot of other material available on Technical Resource Hub. So I'll always try to take advantage of that if you want to learn more about Visum and some of the settings. But let's keep going on here. So once we have all the network elements in place, the next step is to, you have the zones, you have generated demand. So next step is to convert that demand into matrix format. And for that, there is a matrix element or matrices. So matrices, they contain OD pair data, origin and destination, and origin and destinations in Visum are always zones. So you can find where to find matrices in Visum. So let's go back to the version file, and you would find matrices in the network panel, and here in this right next to where it says network, you will see a matrices tab. So if you click on that, it would open this matrices panel where you can access different matrices. So before we do that, let me quickly switch off the stop points and lines layer so that we have a clean slate here. And we do have the links turned on. Maybe we can turn on zones as well. So let's go back to the matrices tab here. And there are two types of matrices. So matrices can store either demand data, meaning number of trips going from one zone to the other zone. These could be segmented by period or mode. So you can create a matrix to store all auto trips in the AM period or all transit trips in the off-peak period and things like that. And usually the demand matrices are generated by demand models. So let's look at some of the demand matrices first, and then we can talk about how you can create demand matrices. So you come to demand matrices and then zone matrices, and then look at data matrices. And here is a list of different demand matrices in NERPMAB, and you can name them, which is more you using an intuitive naming convention. And let's if you want to look at any of the matrices, so since we haven't run this model yet, so you would see when you hover over them, it shows the sum as 0. All right, so let's maybe look at if there are. So it looks like everything is 0. So let me quickly, but we can work with this. So if you want to open or view a matrix, you can simply double click and it would open the matrix editor window. And as you can see, everything is 0 because we haven't run this model. And some of the cells, they are highlighted in yellow, and those are intrazonals. And and ABMs do produce intrazonal trips. So when you'll run the model, you would see some values here. And then the row and column totals are also displayed in the matrix editor window. And then you can manually edit matrices, but then for this model has around 2,500 zones, so it can be very cumbersome to manually edit matrices. So generally you would import matrices, or matrices could be generated by demand models. When you do a trip distribution, that process generates trip matrices, or you can convert an ABM trip list into a trip table, and that way you can generate a trip table. And there are a lot of operations that you can apply on matrices. So you can either select matrices directly, or you can um, select matrices by properties, or you can apply a constant value to them. So there are a lot of operations that you can do on matrices to generate matrices. So you can apply a growth factor, or you can uh, go to the procedure sequence. So let's quickly go to the procedure sequence. And in the procedure sequence, there is if you go to this create operations, which is if you want to add a new step to your procedure sequence, this is where you go to create a new operation. And you can go to the matrices folder, and then you can go to a combination of matrices and vectors. So if you want to generate a new matrix, matrix which is a combination of some existing matrices, you can use this feature. And this is used quite often. So let's say if you look at the network assignment step here, and you would see a lot of combination of matrices and vector steps. So what's happening here is, before assignment, NERPMAB maybe has various model components, right? There is auxiliary demand, there is uh, ABM, and they all generate different trip tables. So ABM would generate trip tables for residential demand, and then all the auxiliary models will generate trip tables for specific auxiliary demand. Now, when we assign, we usually assign by modes or demand segments. So you got to combine all those matrices together, and this is a feature that you use to combine different matrices together to generate final trip tables for assignment. Okay, so and the next set of matrices are skim matrices. So skim matrices could be both input and output, and they usually represent zone to zone impedance. It could be zone to zone travel time, or distance, or fare, or some sort of cost. So this could these are generated by the skim procedure, and then they could also be an input to other processes or other operations in the model. ABM requires skims, so they act both as inputs and outputs. And again, if you want to look at any of the skims, you can again double click the matrix name, and it would open up in the matrix editor. Okay, so that was all about matrices, and we covered this. There are two types of matrices. We looked at demand and skim matrices, and then this is how you open a matrix. And okay, yeah, this another good feature of matrix is, so let me just quickly close some of these windows here, and we can come back to these later if we need them. And then let's arrange the tiles here vertically so that we can see both the matrix editor and the network at the same time. And let's say if I click on any of the cells in this matrix, it would actually show me graphically, which flow is this cell representing. So it can be very useful. Let's say if you have a trip table and you want to see if you see a very high number or a very low number, and you want to see which OD flow this corresponds to. So you can graphically check uh, the numbers or the cell values in a matrix. Okay, so let me go back here. So we saw that, and yes, we did talk about how to create matrices. Normally, you would not manually create matrices, but usually you would import them or apply operations to an existing matrix by applying a growth factor, things like that, or you can combine existing matrices to produce new matrices. Okay, so once you have your trip table matrices ready, the next step is to assign those trip tables to the actual network. And to do that, you use the demand profile element of Visum model structure. So uh, it defines zone defines the demand data, and then matrices define the number of trips between zones, and then the demand profile sort of decides or defines where those which modes those trips would use to be assigned onto the network. So let's again go to the version file here, and maybe I can close this. And you can access the demand profile settings from the demand menu. And when the very first item here, the transport system modes and demand segments. So, in your model, there'll be a lot of transport systems. These are, modes, the actual transport systems. And then these could be grouped into modes. So, all the different transport, let's say public transit transport systems could be grouped into a single transit mode. And that's what is happening in this model. There are different transit submodes, and then those are all grouped into a single transit mode. And then the modes could be grouped into demand segments. So in this case, the modes and demand segments are pretty much the same, but you can combine them into demand segments. And demand segments is what decide how the demand segments get assigned to the network. And to see that, let's go back here. Let's go to demand and look at demand data. So demand data is produced for each demand segment, and then each demand segment is associated with a matrix. So that is how once you have a trip table, using this demand profiling and defining the demand data settings, you decide which trip table corresponds to which mode and how it gets assigned onto the network. And then there are also settings for if you're using a time series or demand time series in your model, you can use those as well. But in this model, we sort of recycle through matrices for different periods. So let me go back here to the matrices tab, and in the zone matrices, you would see the first 5 matrices. So these are sort of the trip tables that get assigned, to the network. And if you, let me go back here to the demand data, and you would see here. So these are the 4 or 5 matrices that we have designated for each mode. And then we recycle these when we, every time, let's say if you are doing AM assignment, then the AM trip table or AM demand is fed into these trip tables. And then when you're doing PM assignment, the PM demand is fed into these matrices, and so on. So that's how you define the demand profile for your model. And we looked at this, how different modes can be combined, transport systems can be combined into modes, and modes into demand segments, and then we looked at demand data. Okay, so we did go through user-defined tables, but that's another important element in NERPM AB, because a lot of the settings and miscellaneous data is stored as user-defined tables. Okay, so let me quickly go to Visum again. And you can look at the list of all user-defined tables by going to table definitions. And then this would list all different types of user-defined tables. And if you want to look at a specific user-defined table, you can go to user-defined tables and go to table entries, and it would open different user-defined tables. You can select, let's say if you want to look at EE trips, then you open that and it would open the EE trips user-defined table. So all miscellaneous data and settings file are defined as user-defined tables. Okay, let's keep going here. So finally, the most important element of model structure is the procedure sequence, which sort of provides a framework to define, what operations to run and in what sequence to complete a model run. And we will, there are different things, different operations that you can include in a procedure sequence. You can call Python scripts to interface with other third-party tools. You can implement skimming, trip distribution, assignment, feedback, and there are a lot of things. If we looked at how to, if we open the procedure sequence here, and if you go to create, it would show you different operations that are available, and they are grouped by different tasks here. For example, for assignments, there are different operations, and then there are a lot of miscellaneous operations, and then matrices related operations, and so on. Okay, let's go back here. So that was all about model structure. Now let's quickly go through the model directory structure. So hopefully you would have gotten a chance to download the model setup now, and you would have gone through this model directory structure. One directory that we did not look at earlier was the scenarios directory. And the NERPMAB currently includes 2 scenarios. So the scenarios directory is where all the scenario specific inputs and outputs are stored. So for each scenario, you would have a scenario directory. And currently, if you would open the scenarios directory, you would see these 2 subdirectories. And each scenario directory sort of has the same subdirectory structure. So it has a input and output folder, and input includes a DASIM input folder, and output would include DASIM, HTML, and a temp folder. So in NERPM AB, the scenario directories, they include inputs only for DASIM, because all the other inputs, mass data, network, and all the other miscellaneous inputs required for running auxiliary models or any other operations, everything is stored in Visum. So only DASIM specific inputs are stored in these scenario directories, and also only the DASIM specific outputs are stored in the scenario output directory.